How do we find out what Oracle is doing? Several techniques. AWR reports I'm not going to look at, we don't have time. AWR reports, you'll only have access to them through your DBA. And as we worked out earlier, none of you are database administrators. But they're a useful tool for your database administrator to work out what's going on, which SQLs are running, which SQLs are killing the system. AWR reports and StatsBack reports. I'm going to skip over that. We will go on to looking at the explain plan command, the Autotrace facility, and use of DBMSX plan. So, activity reports, skip that for now. How do we read an execution plan? Top to bottom, left to right. I'll build up an example slowly so that we can get some sort of an idea from the beginning, an easy introduction to reading the plan. So, I'm going to again, I've got that set, I've set Autotrace on explain. I'll come to the syntax later on, but this is the easiest way to get an execution plan. Well, let us try select star from AMP. Back come 14 rows. There's the plan. Now, you read the plan, top to bottom, left to right. So, start at the top, operation ID 0. It was a select statement. Go down, operation ID, operation 1 was a full access, table access full, and that's it. Simple plan. We implemented the select statement by doing a scan. Okay.
John, at this point, can you take a second to talk about rows, bytes, cost, time?
Sure. This is the number of rows that Oracle expects to be returned by the operation. Oracle thinks that there are 14 rows returned by that full scan. And guess what? Oracle is spot on correct. The bytes, this is to do with the traffic being sent back, the actual number of bytes being sent back from one operation to its parent operation. This scan is a child of that select. It's returning 532 bytes to that operation, which will then get returned to us as users, of course. So this is the volume of data being transmitted, estimated. That's the number of rows estimated being transmitted. And cost is that no unit figure that Oracle has assigned to it. And it's assigned a cost of 3. We'll come back to that and see some more costs later on. Time is basically meaningless. It's really only backward compatibility. Because in the old days, going back to release 7, cost was based on I/O, and you could calculate our average I/O time times number of cost units, that would give you a time. That calculation is no longer really valid. Typically ignore that column completely. So let's go on to a slightly more complex statement, where empno equals 7934. I think that's Mr. Miller. It's Mr. Miller. And our plan is slightly more complex. So how do you read the plan? Top to bottom, left to right. There's a select statement, which has one child, which is index access by row ID. That has one child, index unique scan. You navigate down and to the right until you can't go any further. The first operation is ID number 2, the index unique scan. Note there's an asterisk there. That tells us there's a predicate down here. ID number 2 is applying a filter, empno equals 7934. We are searching the index to find that key. That's the first operation to execute. Having found that key, control goes to the parent, and we do the access into the table to retrieve the row. So the execution order is 2, 1, 0. Now let's make it more complicated. I'll do a join. Select star from emp, natural join depth, where empno equals 7934. Bit more complicated. We navigate down and in. The first operations start running here. Oh, by the way, DBMSX plan, that's the tool that generates this formatted output. Child operations are indented from their parent. The first operation with no child is the first to start. Okay, The first operation, going top down, left to right, is a select. The child operation is indented by 1. It has one child, which is operation number 1, the nested loop. The nested loop has 2 children. How do I know that? Because there are 2 operations indented at the same level beneath it. Any join, nested loop, hash join, merge join, always has 2 children. So, first operation is the select statement. The select statement has 1 child, which is a nested loop. The nested loop has 2 children, which are the access to emp and the access to dept. Operation 2 has 1 child, which is operation 3. It's beneath and indented by 1. Operation 3 has no child. There's nothing immediately beneath it that is indented further. So the first operation with no child is ID3, index unique scan. That, therefore, is the first operation to run. The first operation with no child is the first to start. So we start by doing an index unique scan. There's an asterisk there, tells us there's a predicate. Aha! So what we are doing is searching the primary key index to find the row ID of employee 7934. Once that child operation is finished, it can return control to its parents, and we retrieve the row. Then we go to the nested loop, which is the parent of ID2. But the nested loop has 2 children. So having completed this, control now goes to the nested loop's second child, which is ID4. But ID4 itself has a child, so we can go down to there. So the next operation to run is in fact 5. We do an index lookup into pkdept, and that's using the join column. Having got the row ID of the department row, we retrieve the row. And at last we can do the join. So the order of execution is 3, 2, 5, 4, 1, 0. 3, 2, 5, 4, 1, 0. Note that some operations are iterative. Coming back to the number of rows, here you see Oracle expected to get 1 row back. Right. And indeed it did. So, the cardinality is number of rows to be returned. It will flow back to the parent. So there we go, that's the basic. What do you have to note? The join order. In what sequence the table's joining? Well, we're joining emp to dept. Well, remember the rule of thumb from the last chapter, you join small to large. Well, index unique scan, we've got a primary key lookup, a primary key, an equality predicate on a primary key. Oracle knows with absolute certainty that that predicate is going to return either 1 or 0 rows. Therefore, that's a pretty good choice to start with. Right. Whereas there's no predicate on dept. So it doesn't know how many rows are going to come back from dept. And we know because of the constraints, but never mind that. Oracle doesn't. So that's the order. It's joining emp to dept. Access methods, in this case, indexes. Oracle is relying completely on the cardinality estimates. Are they in fact correct? Let's try a different query. Select star from emp, natural join, dept, where job equals salesman. This is your next check. I've got back 1, 2, 3, 4 salesmen. And now we see interesting situation. First process, scan emp. Because the first operation with no child is ID3. Select has 1 child, which is that nested loop. That has 2 children, which are 2 and 5. The first child is 3. And 3 has no children. There's nothing indented beneath it. So we're scanning emp, and here you see 3. There are 14 rows in the emp table. This tells us nothing about how big the emp table is. From this plan, you do not know if emp has 1 row or 1,000,000 rows. All we know is that Oracle thinks that after applying the filter, there are 3 rows left. In fact, it's wrong. There are 4 rows left. So always check those cardinalities. And the real world, and it expected 3 rows, it got 4 rows. In the real world, it might expect 100 rows and get 100,000. You must check those estimates. The unique scan, of course, it does the lookup. That's always going to return either 1 or 0. So there we go. That's how to read these things. How do you generate them? Oh, join order, join method, access methods. Are the cardinality estimates correct? Where are the filters being applied? Query rewrites. I showed you from our challenge at the end of the last chapter. A lot of rewriting going on. 5 statements rewritten to the same structure. Cost. How long will the operation take? But it has no units. It takes account of I/O and it takes account of CPU usage. You can see here it's costed that at 0 because it's going to be so fast. The cost of an operation includes the cost of its children. So what we have here is, let's take a different example. I'll get rid of the filter. Right. Ooh, I don't actually want to do that. Yes, I guess that will do. Now let me take a different example. Natural join depth where dname equals sales. Right, now I'm not getting that. I'm going to take a better example, I think. I'll remove the predicate entirely. Oh, of course, I know what I've done. I'm on optimizer mode first rows. That's why I'm not getting quite the results I'm expecting.
Sorry,
I'll go back to the all rows default. Yeah. Oh, dearie me. There we go. I'm now on the all rows version, and now getting something that makes a bit more sense. So take a look at this example here. I've joined emp to dept with just on department number. And we see here the plan. Question for you, and I want this in the chat, please. What's the first operation to start executing? We will not proceed until I get a correct answer. First operation to run. Spot on. Thank you for the answer. You're getting there. Okay, second operation, please. Second operation. Close but no cigar. You've got it. Neil, again, close but no cigar. Neil and Charles, you both made the same mistake. Yep, you're right then. You both made the same mistake. You went straight down to there. The first operation is that. But immediately following that, once that's completed, control returns to the parents. Only then can we go to 5 and 4. Right, so almost there. Well done, those of you who got there. So we search the index, we retrieve the row, then we do a full scan and sort the results. So we're searching the index, getting the rows, and that's going to give us rows in index order. Then we do that, sort the results, get emp in department ID order, and then we join the result sets together. So 3, 2, 5, 4, 1, 0. Now, look at the cost arithmetic. That's been costed at 1. Cost of 1 unit to scan the index. The cost of the parent includes the cost of the child. So that 2 cost units for that includes that 1 cost unit. So what Oracle has done is it's assigned 1 cost unit to the full scan of the index and 1 more cost unit to retrieving the rows. So the cost of the parent includes the cost of the child. Coming down to 4 and 5, we've got a full scan of emp costed at 3. The sort join is costed at 4. So 3 units, but that includes the child. So we've added 1 more unit to get to there. And look at that, 25% has suddenly jumped in, percent CPU. This is an indication of whether the cost is I/O or CPU, but it's totally inaccurate. But it may be useful, but don't rely on it. So it was 3 I/O units, then we added a 4th unit, which was all CPU to do the sort. But you can't really rely on that. So 4 and 5, total cost of 4. 2 and 3, total cost of 2. So guess what? The cost of the merge join is 6. 2 plus 4. So remember that. The cost of the parent includes the cost of the child. And then, of course, the total cost is 6. So, cost, a relative measure. The slowest part of the statement was scanning and sorting emp. And of that, the slowest part was the scan. So the slow part was that. And if you were trying to tune things, you might try maybe to optimize that. Maybe there'll be a quicker way of doing it. So, there we go. All done under statistics, of course. Explain plan. This is how we get one of the most useful tools you'll find. The explain plan. Set Autotrace. I'm just going to disable the Autotrace. Explain plan for. And you give it a statement. Explain plan for example, select star from depth where depth no equals 10. Explain plan for. You just do that. Then what that happens, it does a hard parse. Remember the execution cycle, parse, bind, execute, fetch. It does the parse, but nothing else. So it generates a plan, optimizes it. You get the results out, it writes the plan to a table, the plan table, get the results out with the DBMS xplan package. You'll see that in the next slide. Select DBMS xplan.display. And I'm just going to use totally defaults. I'll show you the package in a moment. And I shall .display. Oops, sorry, syntax. Select star. It returns table DBMS xplan.display. And that will show me the plan. So typical usage, explain plan for, give it a statement, then run that to see what the plan would be. That's your standard usage. There are a few variations. Note it doesn't peek bind variables. It doesn't do that. So I'll go to a different schema, a slightly more complex schema than Scott, and let's have a look at this. Explain plan for, and I shall run some, let's see, explain plan for select star from employees where department ID equals 1. Equals 10. There's department 10 now, I think. Then use DBMS xplan to show it. So I'm scanning the employee. It wants to use an index because it expects to get one row back. It thinks there's only one employee in department 10. Let's try department explain plan for department 50. Oops. Wrong bit of code. Explain plan for. There we are. Explain plan for select star from employees where department ID equals 50. That's done the hard parse, generated a plan. What is the plan? Full table scan. Interesting, isn't it? So when I give it select star from employees where department ID equals 10, it gives me an index range scan. When I give it department ID equals 50, it gives it a full table scan. Why? Why the difference? Because this is of vital importance to our understanding of why the optimizer makes certain decisions. Think of statistics. Think of histograms. Oracle knows that there are a heck of a lot of employees, 45, in department 50. So index use is really inefficient. So it's gone for a scan. And this is one of the things you must check. Maybe Oracle's making some horrendous mistake there. What if we had it with a bind variable, explain plan for, where department ID equals :B1? Now Oracle's got a big problem. It hasn't got a bloody clue. It's just made a complete guess. And that's a major issue, use of bind variables. They totally confuse the optimizer. So, it doesn't peek the bind variables. It just takes a complete guess. And it thinks it's going to get 10 back. Who knows how many we'll get back? Oracle certainly doesn't. So, explain plan may not tell the truth. And a common reason is bind variables. But it could be any number of runtime factors as well. It predicts a plan, but it may not be the one that we use. There might be changes, parameters. Think of that setting I made for optimizer mode. That could push Oracle towards a totally different plan at runtime. When I generate this execution plan that's based on select star from emp, where employee by department ID equals 50, Oracle's developed a plan based on full table scan. Maybe my end user has optimizer mode set to first rows. In that case, Oracle would almost certainly choose the index, because that would get something back to the user faster, even though the total cost would be higher. So you don't really know that explain plan will tell you what's actually going to be happening. And there are any number of advanced features that influence that. AWR StatsFact reports, I said we'll skip over to them. You won't have access to them unless you argue with your DBA. Autotrace I've been using a lot. It's a really convenient tool. What it does is it runs the statement. And that's important because remember, explain plan does not run the statement. Well, that's good and it's bad. If the statement takes 5 hours, you don't want to run it for 5 hours just to find out the plan afterwards. You want to use explain plan and make a few intelligent guesses. Whereas Autotrace runs the statement, and then it runs explain plan against it. And that gives you the result of the query. It gives you the result of the query followed by the predicted execution plan. So you get reality, then what was expected. And you also get the actual execution statistics. Very useful in conjunction with timing. So I'll do it. I will set Autotrace on, purely using defaults. Well, explain plan, then I'll run select star from employees where department ID equals 50. Back came 45 rows, which was bang on the money for the estimate. And Oracle thought it was doing a full table scan. Okay, let's try where department ID equals 10. Back comes 1 row, Jennifer Whalen, and the estimate, bang on the money. It was right on, 1 row. Right. And then we see consistent gets and so on. Recursive calls is parsing, by the way, and consistent gets is the reads from cache, and just 1 physical read. So what do you find with Autotrace, particularly the way I ran it? I just said set Autotrace on SQL Plus facility. It runs the statement to completion. So you see the results, then you get the expected execution plan, and then you get execution statistics. Very useful indeed. There are variations. We can suppress these stats, or you can suppress the plan. For example, if I use explain, that will suppress the statistics. So if I now run that, I just see the plan. I see the rule. Conversely, I could give it the keyword statistics, and that will suppress the use statistics, and that will suppress the execution plan. We just see the runtime. Whoops, we just see the runtime stats. So, very useful indeed. Trace only is an interesting option that suppresses the output. And if your query is returning 1 million rows, you don't want them scrolling through your SQL Plus screen. Apart from anything else, it will distort the performance because of SQL Plus having to show it. So trace only suppresses the output, but it does run the statement. DBMSX plan then is the package, is the clever way to do it. Describe DBMSX plan. You may have to ask your DBA to give you permission to see various views before you can get the best out of it. The DBMSX plan, with each release, it gets to be more of a horrendous package. The syntax I've used so far was the most basic function there is. DBMSX plan dot display. That function returns a table, and by default, and the defaults for every argument, it shows you the output of explain plan. So DBMSX plan dot display formats the results of an explain plan command. What's much more interesting is display cursor. because that can show you the truth. That will dive into the SGA and show you. Now, it will show you what actually happened. So let's find out. What I'm going to do is create a variable, var b1 number. Okay. I shall execute set b1 equal to 10. Right. Well, I'm sure you remember that when I did an explain plan, well, let's just do it again. Explain plan for select star from employees where department ID equals 10, and then select star from table DBMS. So what DBMS xplan.display, and this will show me the predicted execution plan. Index range. I'm just going to set Autotrace off. Do that again. Right. Oracle expects to use an index range scan for that query. Now I'll run the statement. Oops. So I've actually executed the statement, and back comes one row. To see what Oracle actually did, I go to Display Cursor, and by default it will show me the execution plan for the last statement executed in my session. And it was indeed an index range scan. So that's the truth. Now let's try a different one. I'll set my variable colon b1. Now I'll set it to 50. No, I'll leave it on 10. Leave it on 10. Right. Explain plan for colon v1. Right. Explain plan for, I should say. Explain plan for. So the predicted plan is use an index. But let's actually run it. Oops, hang on. Did it use an index? Oh, var v1, sorry. Execute. v1 becomes equal to 10. Right. Oh, I haven't defined it. I must have changed. Sorry, var v1 number. I'm doing things in slightly wrong order. That's better. Right. Actually run the statements. So Oracle predicted use of an index to get back 10 rows. And when I have it on 10, get the plan out of the cursor. And yes, it did use an index. What, however, if I set my variable to department 50? Right. Well, the explain plan for that statement says use an index. Well, does it? With v1 on 50, I get back 45 rows. It's using an index, and the estimate is totally wrong. Try it again. Run it a second time. Do it a third time, and we'll see some interesting effects coming through. Oops, let me just give it a fresh start. I'm playing games of the optimizer, which is always a bit dangerous. Do it again. It used a totally different plan. So the prediction was to use an index. In fact, it did a scan. So that's what you've got to be aware of. You've got the predicted plan, the actual plan. All sorts of formatting options. These are typical usages. Explain plan for, followed by that. Or run the statements, followed by that. Or, for more sophisticated tuning, identify statements that are parsed and cached in memory by the SQL ID number and the cursor child number. And of course, in our exercises, we go through all of these. Statistics level is important. That's the amount of information being gathered. By default, you'll find that statistics are set to typical. That's enough for normal usage. But when we're tuning SQL, we will normally raise it to all. That gathers much more detailed information about what Oracle is doing. But the SQL tends to run a bit more slowly. Right. And there's all sorts of formatting you can do to show extra options. And the final way of working out what Oracle is SQL Trace. This you'll need to discuss with your DBAs. SQL Trace is serious. SQL Trace requires some permissions. It has definite performance implications, but it is often, as the last resort, what you will have to do. Because everything I've done so far, I knew what the SQL was. I knew what SQL I was looking for. But if all you've got to go on is this batch job takes too long, and the batch job has 500 statements, you won't know which one is causing the delays. And that's where SQL Trace may be invaluable. You will trace all 500 statements, the whole 5-hour batch job, and analyzing the trace file will show you which SQLs need to be tuned. So that's the conclusion of investigation. How do you find out what Oracle is doing? You've got to identify the problem SQLs. Then get execution plans for them. Actual plans, predicted plans in various ways and various sources for getting the plans. Identify within the plan the high-cost operations and work out what's going on. Always compare the estimated cardinalities with the actuals. For example, when I ran this statement, V1, well, I got back, well, that was the display cursor. I actually got back 45 rows because V1 was set to 50. Oracle didn't expect 45 rows. Oracle expected a lot fewer than that. Somewhere or other. Oh, that point there, it was expecting only 1, but it got 45. Disaster. So, these are things you need to think about then. Comparing actuals to reality. That then concludes the investigation. And I'll pass back to Dave now to wrap up.
Thanks, John. So the last page of Lesson 2 includes a challenge, and we do hope that you'll spend a few minutes trying to determine the order of the execution plan, the order of the operations in the execution plan, and the join order. Email that through to us, john.watson@skillbuilders.com or dave@skillbuilders.com.